In this problem, we have a data table of children, some of whom do chores and some of whom don't. Also, some of these children receive allowance while others don't. We'll be asked a series of probability questions based on this table. But before we do anything else, let's find all of the category totals first. In order to find all of the category totals, we'll use the sum formula. Let's begin in cell B4. We'll say equals SUM, open a parentheses, and then select all of the data above it. Make sure not to include the data label that says chores. Select only the numbers. Close the parentheses, and this gives us the category total for the children who do chores. If we use the black cross in the bottom right-hand corner of this green box, we can also calculate the number of children who don't do chores, 288. We can also find the children who get allowance and don't get allowance, also by doing a sum formula. We'll say equals sum and select both of these columns. Make sure not to include the data label that says allowance. Select only the numbers. This gives us the total number of children who do get allowance. If we use the black cross and move down, we can see 418 children do not get allowance. And in the bottom right-hand corner, we have the overall total of 950 children total. We'll mark that in gold, and we'll mark our category totals in blue. So we'll be using the category totals and the overall total to find these probabilities. Question B asks, what is the probability that a randomly chosen child does chores? So we'll need to get the category total for the children who do chores, and also get the overall total. The equation we use to find the probability is we take the children who do chores and divide by the overall total. If we look in the table, next to chores, we can check the category total located in the bottom left corner. 662 children do chores. Our overall total in gold is 950. Therefore, if we would like to find the probability of doing chores, we can take equals 662 divided by 950. We don't have to retype the numbers, we can simply click on the cells. And we get a probability of 0.69684. We can also go to the home menu and reduce the number of decimal places by clicking decrease decimal several times. We can say our probability is 0.697. Part C asks, what is the probability that a randomly chosen child from the study receives allowance? To find this probability, we'll take the number of children who do get an allowance and place that on the top of this fraction. On the bottom, we'll place the overall total. Now, let's collect our data. First, we'll enter the labels in column A, and we'll consult the table again, first looking for the allowance and the overall total. Our category total for allowance is located in row 2. That will be 532, which is across from the word allowance. As before, our overall total is in the gold box, 950. We enter 532 for the allowance and 950 for the overall total. We can say our probability of receiving allowance will equal 532, the number of children who do receive allowance, divided by 950. This gives us a probability of 0.56 of receiving allowance. In Part D, we are asked, given that the child from the study receives an allowance, what is the probability that he or she does chores? When we work probability problems, we need to be on special lookout for the word given. When you see the word given, that means look only in a certain category. This also means don't use the whole table. Now, if we look further in the sentence, it says that the child does receive an allowance. This means we will only look at the children who receive an allowance for the purposes of question D and not look at the whole table. So let's have a look at the table and copy only the part where the child receives an allowance. We can see among the children who receive an allowance, the category total is 532. However, the question asks about the children who do chores and receive an allowance. So we're going to look only at this piece of the table and look at the children who do chores and get the category total as well. So the children who do chores are 390 and the category total is 532. Once again, we're not using the overall total because of the word given, which I've boxed in blue. Now we'll find the probability of doing chores within this category. That is, the category is receiving an allowance. So we'll take the number who do chores, divide by the category total, giving us 0.733083. Once again, we can go to home and reduce the number of decimal places. So the way this is oftentimes said is the probability of doing chores given that they receive allowance. Now part E is a similar question. Given that a child from the study does chores, what is the probability that he or she receives an allowance? Once again, we encounter the word given. And the category we're interested in is the category where they do chores. So we'll return to the top and we will copy only the part where they do chores. Now we are being asked about the probability that the child receives an allowance. So within this category, let's look at the number of children who do receive allowance. And we'll get the category total as well. We can see there are 390 who receive an allowance, and the category total is 662. Again, we're not using the overall total because of the word given. I'll write this again just for good measure. So what we're finding here is the probability of receiving allowance given, that's the vertical bar, that they are doing chores. And so we'll take the children who get allowance, divide by the category total, and this gives us 0.589124. We can again reduce the number of decimal places by going back to home, to the number section, and clicking decrease decimal. Here's our plan of attack for this question. First, we find the probability of receiving an allowance. And then we also find the probability of receiving an allowance given that we're doing chores. Now, if these two probabilities are equal, we can say the events are independent. Now, if they're not equal, that means they're dependent. Now, we've already calculated these probabilities in previous steps. First, let's find our probability of getting an allowance. We found this in part C, and we see that the probability of getting an allowance is 0.56. Let's also look at the probability of giving an allowance given that the child does chores. We calculated this in part E, and we found that the probability is 0.589. Now we can see that the probabilities are not quite the same. Your probability of getting an allowance is 0.56, but if you also do chores, your probability increases to 0.589. This means that if you do chores, you affect the probability of getting an allowance. Therefore, we can say that doing chores will influence your gaining of an allowance. And since the chores do influence your allowance, we say that these events are dependent. So in order to find if events are dependent, first check the probability of the event, that is, getting an allowance, and then check the probability again under the condition that you are doing the other event, that is, doing chores in this case. So since our probability of getting an allowance is different if we already know that the child does chores, we can say the events are dependent. This will be true anytime you end up with different probabilities.